Hello. We're going to be going really fast here. We went from slow and careful, and you will follow everything's going along. Now we're going to go just really fast. There are a ton of options in Condor Submit. We call them commands. I'm going to put half of them up on the slides explicitly. The other half will be shown by pattern. There are hundreds, but you don't need to know hundreds. I just want you to get a sense of what's there. And then when it's time for you to use it, you can look it up. All of these are listed in the Condor Submit manual. As I go through the slides, things you see in green will be submit file commands. And then I have two different fixed pitch fonts, one that I use for example statements you would put in a submit file that aren't simply commands, but the whole line and so on. And the other is things you would put on the console, things you would type in a command prompt. Okay. So Condor Submit is not class adds. This is our language for describing jobs. You might call it a JCL if you're an old guy like me. It's a language for describing jobs that gets translated into this class add that actually gets used inside. We have a library that does this. We call it submit utils, and you can invoke it from Python. You can invoke it from Condor Submit, and they both give exactly the same results from the same input. What this thing does is it reads through this file. We call them submit files, or sometimes submit description. Description would be, because it doesn't have to come from a file, it can come from a hash table in Python. But we read through this building a table of key value pairs. The last definition of each key wins. The keys are case insensitive. I will generally show them all in lowercase because that's the convention, but they're case insensitive. It just doesn't matter. Then when we hit the line that says Q in your submit file, at that point, we fire up our submit utils library. We take that table of key value pairs and we build job class adds with it. And if you're doing this properly, we build lots of job class adds, right? It might be tempting for those of you who have experience with some sort of scripting language, say Python, to write a Python script that generates a submit file that submits a single job, and that will work, but it scales much better in Condor if you give Condor Submit a description of 10,000 jobs with a single submit file. And so I want you to think in those terms. In your submit file, there is one required command. You must say either executable or Docker or container image, one of those two. And the reason you don't need an executable is because a Docker image or a container image is allowed to have a built-in implicit executable. Generally speaking, you will still use the executable statement even if you have a container image, because that is just a better way to reuse those containers. Then if you're using anything other than vanilla universe, you need a universe statement that tells us what universe. And that universe statement, for the most part, does two things. It enables a whole bunch of submit commands based on the universe. And then later on, it tells the AP and the execution point certain specific things to do for certain universes. I should point out, we do have a universe called Docker and container. Those aren't real universes. We call them toppings. These are universes in the sense of submit. These turn on specific submit commands. But then the universe that we hand off to the rest of Condor to process is just vanilla. The other thing you're going to want, but is not strictly speaking required, of course, is arguments. I want to do a quick digression here to talk about submit variables and macros, or we call them macros. We call these a lot of different things. submit commands and submit variables are really the same syntax. The only real distinction here is a submit command is a variable that the submit utils library understands. It has a schema. All the rest of the variables are just things you create for your own purposes, like the sample that Christina used. That's just a submit variable, but Condor submit doesn't understand that intrinsically. It only understands it when it is used inside these dollar expansions. But if you want to use a submit command inside one of these dollar expansions, that works, right? You can say dollar arguments and it'll pick up whatever the value of arguments is and substitute it in that place. There are a bunch of built-in variables to help you do this generalization. Row, item, and step are automatically values that increment when you use the queue, the multi-item queue statement. So if you say Q23, then step counts from 0 to 22. If you use queue from files matching star.dat, then item iterates through that list of files as we're building this whole collection of submitteds. All right. Cluster is a unique identifier that identifies this particular submit. It is handed out to you from the AP at the point you request to submit the jobs. The process is one for every job in this submit file, and it goes from 0 and counts on it. There's something we recently added just as a convenient feature. Job ID expands to cluster.process, which is the way we normally express these in our user interface. There's also submit time. This is the time at which we contacted or we built the job ads from the submit description. And there's a day, month, and year, which are pieces of that time as well. Submit file, if you submit using the submit file, is the path name or whatever you specified as the submit file. And then there are the $F macro and the $base main macro can be used to extract pieces from that. So you can say, I want just the base name, I want just the path, I want just the first part, like the last directory of the path, and so on and so forth. Also, in this dollar expansion kind of thing, this variable substitution, there's a special case we call dollar expansion, where if you put $2 signs at the beginning, then that is not expanded at submit time. That gets written into the job ad and gets expanded when the job is assigned to a slot to begin to run. And so you can pick up attributes from the slot and inject them into the job, that execution instance of the job at the last minute. And this is a great way to say, I want to pick up the architecture, or I want to pick up the operating system of the job and pass that, for instance, as an argument to my program. I can pick up the number of GPUs that I got assigned and pass that as an argument. Or $$ assigned GPUs is actually the names of the GPUs that I'm permitted to run on. Pass that as an argument. This can be very convenient. There's also a magic one here, $Condor scratch dir. Works only when used with the environment statement in the submit file. It does expand everywhere, but it only expands to the directory you run in the environment, because there's extra work done at the execution point. We don't know at the time we match you to the slot what that directory is going to be, right? And so there's special code in the execution point that picks up this magic string inside the environment and says, oh, I know, you meant this to be the directory that you're running. Okay, and now we get on to the submit commands. There's some for containerization. Two key ones are container image or Docker image. You need to use one of the other. If you use container image, then we look at what you actually specify as the value. And if it starts with Docker, then that means I want to match a resource that understands how to pull from Docker repos. If you say .sif, then that says oh, I need to match with a resource that knows how to start a container against a CIF file. If it's anything else, then we expect to match a resource that knows how to start a container from a directory tree. Just run, this is the container contents. And if you say Docker image, this implies you want really actually Docker and no other Docker-like thing. And the reason for this is because there's a few things that Docker can do that the Docker-alikes can't necessarily match. If you specify container target dir, that says inside my container, when I look at the sandbox, this is the directory I expect the sandbox to be mounted at. This can be convenient. If not, then the sandbox inside will be the same as the sandbox outside. Docker pull policy, if you're using Docker or a Docker-alike, is whether or not you want to force a refresh of that image from the repo every single time the job runs, or you're willing to work with a cached image. Of course, it's better to use a cached image if you can, but sometimes you really want to force that refresh. For Docker, we can do actual container services as well. There's a way to say to Docker, I want to run a service inside this container. Please essentially connect the ports in that container to the outside network interface. Of course, for a lot of execute nodes in a lot of pools, you can't get off node. And so that doesn't necessarily mean you can run an HTTP server on some random execute node somewhere, but it can be useful in certain specific circumstances. All right, arguments. Every job should have this. Arguments on environment are essentially how you set up the world, and in particular, especially in the Linux community, it's common to use environment as a kind of argument to your job. This is something we see a lot. There's a special kind of environment, get in equals, which is I want to grab the contents of the current processes environment, copy its values into the environment of the job. This makes a lot of sense if you're running on a shared file system, which mostly means you're not running in the OS pool or any kind of really wide scaled out. And so the get-env is not especially useful for large scale Condor jobs, but it can be fairly useful if you're doing local universe, which is I want to run the job on the access point itself, which is what we do for DAGnet, for instance. Now, something I want to say about arguments and environment, the format's a little weird. The way it does argument quoting, essentially argument collection, is different from every shell you have ever used. And that's because it's shell independent and platform independent. And so you can submit from Windows, run on Linux, or submit from Linux, run on Windows, or submit from either and run on both, because Condor automatically converts to the correct quoting of arguments for the platform that you end up landing. The platform independent stuff mostly uses space as a separator, but if you need spaces inside your arguments, that's a special form we call arguments 2. I've gotten ahead of myself a little bit, sorry. So the arguments and environment are where you want to use particularly these dollar substitutions and to pick these variables up and pass those on down to your program so that you can do submit 10,000, for instance. By the way, I'm not going to go into a lot of detail in this example here. There's a lot of stuff going on. And you should come back and look at this after you know things a little bit better and see if you can figure out all the pieces are, or catch me on the break and I can go through it in detail. There are a lot of tricky things going on here. All right, Every job needs a certain amount of resources. Now, it used to be what we did is the slots had a static amount of resources, and your job just had a requirements expression that said, I want to match a slot that's big enough to run my job. But that's not the way we do things anymore. These days, we mostly have slots or execute nodes that have, say, 128 cores and some ridiculous amount of memory. And you want to request the specific resources your job needs, and then we'll carve off a slot to match that when we run the job. And so we have these resource request things, and this is a pattern-based thing. There's a request memory, request CPUs, request disk, and request GPUs. But you can also do request bandwidth, for instance. If the administrator of the execution point has defined bandwidth as a custom resource, then that will only match execution points that have custom resource bandwidth and have a sufficient quantity to match your job. So you, as a submitter, you can't really make up your own resource types, but the execution point administrators can, and then tell you how to use them. We do this in the CHTC with jobs that want a lot of bandwidth. We call it, I can't remember now. All right. Oh, I'm sorry. One more thing. A special thing for GPUs, and only for GPUs. We realized that for the heterogeneous GPU case, we needed to say not just I need a GPU, but I need a GPU that has a certain pattern, a certain amount of memory, a certain level of the CUDA capability. And so for GPUs, you can, in addition to request GPUs, you can say require GPUs. I want to match only machines that have GPUs with this capability. And when I land on that machine, if it should have multiple types of GPUs, I want to be assigned a slot only that has that type of GPU. This is something that we added late in the 9X series. So if you're running anything earlier than that, this won't work. All right, jobs have input. There is a standard in or input. This is a common problem, actually. If you are tempted to use that as the name of your substitution variable, instead of Christina's sample, you just call it $input, then we're going to connect this to the standard in of your job, which may not be what you want. So you need to be a little cautious about the use of the word input. Then there's also all the other files that are not in the standard in of your job that you want to transfer and reference within. There's also a should transfer files, whether or not file transfer should happen. The default for this is if needed. I would recommend that you set it to yes, because if needed can be a trap, particularly on Windows, where if needed is almost never works when it decides it's not needed. There's also a special case for whether or not you want to transfer the file you mention as standard in, and whether or not you want to transfer the executable. The defaults for these generally do the right thing. There's also standard output and standard error. For most jobs, these are really logging. They're not really your job output. They can be, it's permitted. But normally, you're going to treat these as log files. And once again, you can specify whether or not they transfer independently of this transfer input files if you want to. Oh, and by the way, these two transfer standard out and standard error can stream. That is, they are transferred back in small chunks as the files change. This can be convenient for testing and debugging. It will melt down your AP if you do it in a large scale. So, but it can be very useful for initial testing. The other thing that you can do, this is a little outside the topic, you can actually fetch them. For a job that is currently running, there's a Condor tail that can just pull those files and show you the current value. Your real output files will almost certainly be mentioned in transfer output files. The default for transfer output files is every file whose timestamp is newer and is in the root directory, the root sandbox. If you want anything other than that, then you have to specify and transfer output files. And at that point, we don't transfer based on timestamps. We just transfer what you told us to do. There are also controls for when output transfer happens. You can say only transfer if my job succeeds, only or never transfer if you want to, or an especially useful one on exit or evict. That is, if my job gets kicked, I still want to see this partial output. This is especially useful and more or less required if you want to do self-checkpoint. A new feature, relatively new, is you can specify the destination for output files. You can say, take all of my output files and stick them in this directory over here. In older versions of Condors, you could only use a URL as a destination. And they added it, we added the output to a directory on the AP fairly recently. And then transfer output remaps is if you want to rename individual files during the transfer. There's also a thing we call file transfer plugins. This is kind of outside the scope of the submit language, except to mention that you can transfer your own transfer plugins. So I can say, in this example here, I have a transfer plugin for the unzip protocol. It's this file. That file will then get transferred first before any other, or at least before any other plugin. And then in my transfer input files, I can say transfer foo.zip and then invoke the transfer plugin. And I can pass, what you put here is whatever you want to, but presumably you're going to say, I want to unpack foo.zip. And that will run your plugin. Now, an interesting trick here is this is really conceptually just a free switch, right? This is a program you transfer that runs before your program. And you can do interesting things with this, but it's meant to be used in file transfer plugins. And this takes precedence, by the way, over officially registered transfer plugins. So if I say transfer plugin HTTP, then that's what gets invoked for every HTTP transfer. And you can do some really scary things with that. Logging is something you probably want to do, especially if you use Condor Watch Queue. This is how Condor Watch Queue works, is it looks at the log. There are actually two logs, potentially destination in every job. There's log and dagman log, because dagman wants its own and doesn't want to interfere with whatever the user wants as the job log. If you're not submitting with dagman, then you can just use dagman log for your own purposes. There's a new thing we just added, ulog execute adders. This is when my job begins executing, these are attributes of the slot I want printed in the log. This can be very convenient, and we plan to do some interesting things with this in the future. There's a much more cumbersome mechanism for doing something similar that's been around a long time. A combination of job machine adders, which says when my job is matched to a slot, copy some attributes from the execute node into my job. And job add information adders, which says every time I write something into the log, also write these attributes into the log as an event right after that. There is no guarantee that that is the very next event, though, in situations where there are multiple writers in the log. Here's some attributes for, generally speaking, I call them job correctness. If you say allow job duration and the job runs longer than that, this is total execution time, so sum of all the execution attempts, the job will just go on hold. If you say execute duration, then that's the time of a specific execution event. And if it exceeds this amount of time, the job will just go on hold. So this is for situations where your job gets stuck. For some reason, if it's processing an input file, some simulations do this particularly, they just get into an infinite loop and they never exit. And this is a way to say, if it runs more than an hour, then the result cannot be correct, so just kill it. There's another new thing, relatively new, a way to verify that you're actually processing the data you think you should be processing. If you specify manifest equals true and manifest dir equals some location, then every file transferred will get a file name and a checksum written into the file in this directory, and it will happen on Todd Miller's not here. He's the one who knows the answer to this. I think it happens just before we start transfer, just after we start transfer, and on completion. There's also a check for transfer input and output. If the size of my transfer and input and output would exceed this number, just don't do it, right? I know it's not going to work if I try to transfer a gigabyte of log files back from my execute node, so just don't even. And then there's these generic mechanisms, periodic hold, periodic release, periodic remove, which can be used to sort of roll your own special behavior. Like, for instance, you could implement allowed execute direction using a periodic hold. Please don't. There's also first-class support for job retries. By default, Condor doesn't know if your job succeeds. If we successfully launch it, then any exit code it returns is presumed to be the exit code you wanted, unless you say otherwise. If you say that the exit code of success is 0, which typically it is, that enables job retries. When the job exits with some value other than 0, that means you should try it again up to max retries. So if you use either one of these two things in your submit file, that enables retries. Oh. Okay, I'm out of time. Yeah. Okay, that went really long. All right, so I am out of time. One thing I would like to point out right here at the very end, in my way past the end bit, if you are the administrator of an AP, you can add commands to the submit language. And this is how you do it. And then there's an example.